Hi class, so today we are reviewing ChiSquare. I apologize we weren't able to do this in person, but if you do have questions to follow up, you can always reach out to me and send me a message or contact me about making an appointment on Monday of finals week. So you do have the last exam. The study guide is posted. It will open up on Saturday and it will close Thursday at noon. So you have till Thursday at noon for finals week to take the final exam. If you look in your modules, you will see that we are on week 16. You'll see these review materials, some of which I'm going to go over today. We do have a practice ANOVA. You do have an optional practice exam. Both of these close on Wednesday night, so you need to take them if you're planning to wait to take your last exam until Thursday. If you want to take advantage of the practice, do so before Thursday morning. They'll close Wednesday night. So some other things that we are going over, again, you do have these different slides to go over chi-square. Some big things to understand in chi-square is what is chi-square? And so you've got a couple of slides that share it's non-parametric. What does that mean? That means we don't have to rely on population parameters. We don't rely on using data. It is looking at categorical data. There are some different types of chi-squares, which I'm going to go through and introduce, but this is another test statistic to examine relationships. When we talk about relationships, we can talk about relationships, we can talk about covariance. Both of those are similar. So this unit, you learned about the correlation coefficient. Then you learned about regression, which is a step up of correlation, and now chi-square. So chi-square is typically nominal scale, so that nominal, ordinal, and perhaps ordinal. And you've got a little learning check for you to do, and you can check your answers in class. When we look at chi-square, there are a couple of different options. The first one is goodness of fit. Goodness of fit just looks at one nominal variable. I might ask you your favorite pizza toppings. I might ask you your favorite candy, your favorite soda, etc. And then I am looking at that distribution of preferences and seeing how they align. That's goodness of fit with one variable. When I'm interested in looking at relationships among categorical variables, so two nominal variables, I would run a chi-square test of independence, and that's going to be our focus for this unit. So I gave you, for this lecture, I gave you an example of soda preference. So a lot of marketing research, preference research can be for goodness of fit, again, just one variable. This is sometimes also looking at, I'm wanting to make sure there are differences or there's no differences for groups. So again, no differences goes to the null. If I'm interested in looking at, well, do we see differences if you look across accident rates across those different groups? How is that distributed? That could be, again, I'm just looking at one based on age. How many accidents or what percentage of accidents am I getting for those? And actually would be count versus percentages, and then comparing those distributions. The example we're going to go over today with chi-square goodness of fit is when you have two categorical variables. So this is an actual research study. So they were trying to identify if we give patients entertainment after IVF in vitro treatment, in vitro fertilization, is it related to pregnancy outcomes? And in this case, we are doing something before the pregnancy. So after the IVF, they're either put in the clown condition or the no clown condition, with clown being the source of entertainment, relaxation. You're, trying to get a laugh, relax that body. So they're in that parametric system versus the sympathetic system. And then they follow up and see if the individuals are pregnant or not. When we do a chi-square test, again, it's nominal data. When you work with nominal data, you can only get counts. And so this is some actual count data from the study. So when we look at these, this is showing that 4 individuals who got assigned the clown, 33 got pregnant, 60 did not. 4 individuals were assigned the no clown condition, 18 got pregnant and 75 did not. So again, individuals were randomly assigned, and then we waited and see the outcomes. When we look at this, we can call this a contingency table. Again, these are frequencies or counts. It's also called crosstabs. So I'm just going to go through and take you through some steps with chi-square. I do share the formulas. It is based on outcome minus expectation divided by expected counts. Again, your book, I put O minus E divided by E. That O represents frequency observed, frequency of expected, frequency of expected. And then that's kind of sum up. This is something, if you're doing this by hand, you would have calculated. If you're doing a computer calculates it. So let's go through and talk about this formula and go through the steps, which is including exploring some stuff about effect size. So if you go to slide 24, you'll see we started off with the setup. So this is kind of a 2x2, 2 variables. And then each variable has 2 outcomes, and we're looking at frequency counts. So we went ahead and collected our data. We then would set up our null hypothesis. When you do a chi-square test of independence, independence is your null. If it's not related, there's no relationship, there's no covariance, then it's independent, right? So think of those no relationship is independent, not covariant is independent. Even though, so it's this chi-square test of independence, again, that independence is the null. So you're going to set up your null in research, just like we always do in our hypothesis testing. When we get to step 2, we look at critical values. Critical values, again, I'm not going to have you look at the back of the book, but that is the formula. You don't need to know the formula. You do need to know, though, if I give you a critical value, which connects to this critical boundary, you would need to know what to do with that with all the different test statistics we've learned. So this is the reject the null category. So I didn't mean to move that. That's the fail to reject the null. Reject the null means significant. So if I have something over here, there is covariance, there is a relationship, there's something going on there between those 2 variables. Okay, so again, there's different ways of setting up these hypotheses. This is just one example. I can say pregnancy rates depend on whether one's entertained by a clown or not, because the pregnancy occurs after the entertainment being randomly assigned into groups. Sometimes when you run a chi-square, you can't do that. So you just need to be careful in what you can or cannot do based on, is this a time-based study? So in this case, it is. So then you would go through and do the calculations. We're not going to worry about the calculations, but this is your chi-square. You would connect this number to that to your 3.841 to make a decision. This is how it's calculated. So if you were going to go through and do it, I went ahead and ran through it. Again, you would have calculated all these expected values and then sum this all up, and summing up all of those things gives us the 6.081. So it is significant. So I want you to take a moment and think about that. Step 4, you know so I said it was significant. What does that mean? What decision am I going to make? Reject the null, fail to reject the null. Will I say significant or not? And then explain the context. So I highlighted, this is for clown pregnant, clown not pregnant, no clown pregnant, no clown not pregnant. This is what we observed. This is what was expected. So here we're seeing an increase in pregnancies with the clown, and we're seeing a decrease in not pregnant with the clown, which identifies we are seeing significant enhancement in success rates and lower failure rates in using entertainment for IVF. And there's other things that individuals can use as well, again, keeping that less stress for the mom so that her body's relaxed after having that IVF treatment. When we go through this, we're always going to do effect size. And so, again, you can check your work with example statements I made and contact me if you have any questions. You use Kramer's V. That's our effect size. I would give you a Kramer's V number. Again, I'm not going to have you worry about the formula. And then you would make a decision. When you do Kramer's V in real life, you have to base it off your degrees of freedom, which is something you would have calculated in your step 2. So in this case, just to give you reference, it is degrees of freedom 1. If I gave you something like this, I would give you the degrees of freedom, I would give you the Kramer's value, and then I'd want you to make a statement. So here we're putting into the small effect. And then I've got a couple more question checks for you that have answer keys lower on in the slide. So we've got these 2 question things you can review to check your understanding. So that's chi-square in a nutshell. Part of your homework is going to be, you're going to be given some data, you're going to be working through that information. So part of it refers to this worksheet. This worksheet is posted. I also will have hard copies of it for you to pick up in the classroom on Thursday. So if you were on campus, you could go ahead and pick those up. They'll be in the classroom in an envelope labeled Dr. Bear Stats Class. And otherwise, it is here, all the materials we're using. So actually, if you scroll up, we've got the chi-square one. So this sheet is right here. And so I'm asking you to fill this out. This first question is kind of based on these 3 things. Why is it appropriate to run a chi-square test of independence for these 3 different examples? Again, asking yourself, what are the different categories? Is there more than 2 variables? Are they nominal? Those kinds of things, and justify. Then you are going to pick one of these examples and fill out that crosstab or contingency table. So, for example, for this first one, medicine, are children more likely to get infected with virus A than adults? All right, so I would have children and adults as one of my groupings. And then I'd, hey, got infected with virus A, did not get infected with virus A. And then I'd put child got infected, child did not get infected, adult got infected, adult did not get affected. Again, you're not putting in any numbers there. It's just for you to understand these 4 different categories connected to that question. So again, you're going to pick which one you want to do and figure out they're all 2 by 2s. I then am going to have you think of your own example. So make up an example that would be applicable, connected to psychology. Again, you're going to give me those 2 variables and then give me what 4 outcomes come through there. You then are going to be given some data. So here's the data. Again, you're going to interpret the chi-square. Again, interpret the chi-square. Give me those statements for that step 4, and you're drawing a graph. Here is your data for interpreting for your step 4. I also want you to do effect size. You can get that prompt in the homework. And these are what you're graphing, these 6 numbers here. You will see you do already have a prompt that shows you, I'm putting Republicans and Democrats political party down here. You have 3 categories of different options for voting, and then you'd put your 3 Republican categories, then you'd put your 3 Democrat categories. This is a bar graph, remember, because you have nominal data, so your bars should not touch. Just a general reminder there. Okay, so that's all I have for chi-square. Again, feel free to reach out with any questions. The other things that we're going to do in class that I would have loved to go over with you and have you work together with peers is a decision tree activity. So your options are, I'm going to show you the worksheet in a minute, but you're going to put in these different answers on the worksheet. The other thing I was going to review is what are these differences in research design. So I kind of gave you some definitions there. So I'm going to go ahead and pull up that decision tree activity chart. When we go through and collect data, we are having to first come up with a research question. So our research question is usually based on, is there a relationship going on here, or we're looking at differences or comparing means. Then from there, you would go ahead and ask yourselves these different decisions to help determine what statistics you were going to do. So you would go back. Some of these, 3 of these options are based on relationships. The rest are based on group differences. You then have 3 boxes to put in here, and then you have your rest put here, right? So you're going to fill those in, and there is an answer key posted for you to check your work. And this is a nice resource for your exam. You could also kind of recreate this if you didn't want to print off the sheet. If you do print off the sheet, feel free to fill in all those white spaces with other information if you would like. So that's your first activity. Your second activity was reviewing ANOVA. We're reviewing a one-way ANOVA. I'm having you listen to an NPR clip, and if you're in the slides, you can click on the link. The link is also posted right here. It's a 4-minute blurb. It's about an actual research study. So listen to that. The research study is actually a 2x3 because they look at pain after the surgery, then randomly assign them into these different conditions, audio conditions, and then ask for pain again. For the purposes of us reviewing ANOVA and output, I went ahead and made it a one-way ANOVA. So I'm kind of ignoring we had a pre-measure before our 3 conditions. So I do want you to answer these questions. So what kind of study design it is, between, within, or mixed. It's not mixed because we've got our one-way. What's your IV from the study? What's your DV? And that's explained in the NPR. It's also explained a little bit up here. What were the basic findings from the study that they had shared? Remind me what ANOVA stands for. And then why was ANOVA used for this study? Again, justify based on what you know, why was ANOVA appropriate? So maybe looking at number of groups, levels, conditions, treatments, maybe looking at what level of measurement is my outcome, dependent variable, what kind of level of measurement is my independent or predictor variable. And then this is actual mock data kind of reflecting from the study. I'm likely going to give you output data. And so we're not focused on calculations. We're focused on understanding for this last round of tests for statistics. And you're going to have to recognize, okay, she is going to tell me what statistic it is. So I'm going to tell you it's a one-way. Here is the F. All right, this F, you're not going to have the critical value, but guess what? You will have a reported p-value. So for here, if I looked at this F, I know p is less than 0.05. So I know this F is significant. Remember, F is an omnibus test, so it tells me it's significant, but I need to know more. I need to know the post-hoc. I also give you the effect size. So effect size, one of the effect size that we learned about for our one-way ANOVA was eta squared. So if I gave you eta squared, I expect you to interpret that. It then gives you, I show you the whole spiel for output. So it gives you descriptives. So I might ask you, I might show you descriptives, give you context of the study. So this was on a scale of pain from 1 to 10. So in this condition, group 3, which they were just had noise canceling headphones, these kids had an average of 7 out of 10 on the pain scale. So that's pretty high. So I'd be able to give context for that. I also might ask about context for standard deviation. Is this moderate, large, small, etc.? And actually that's pretty moderate there. It then does assumptions. And so this tells us this was good for us to run that. Again, you just need to know the general assumptions. One of our big assumptions for every parametric test, which is everything except for chi-square, is a nice normal distribution with our data. So that's what, and actually this assumption is checking my standard deviations and variances amongst my 3 different conditions are not too different. So then this is the post-hoc. We need this post-hoc in the omnibus test when we have more than 2 groups. So here we see it's condition 3 that's different from the other 2, and that does replicate the NPR finding. And then this is the graph you might see on here with my 3 different conditions and their pain, and then using confidence intervals, which gives me the majority of spread for 95% of the data that's going on there. And those dots are means. So again, you'll have a key posted for that in the modules. So then the next review activity is looking at regression and correlation. For regression and correlation, again, remember correlation is not causation. So you are going to go ahead and first talk to me about this idea of a third variable. So a third variable is some other way to explain how these 2 things are related. So I'm going to ask that you at least pick one of these 2 options. You could do both, and I'll give you an answer key. It's not going to be exhaustive, but I'll give you some ideas. So let's go ahead and explain this in terms of another example. So I'm going to say rates of eating disorders are related to use of social media in teenage girls. right? So I see there's a correlation between eating disorders and use of social media, right? So these two things are related, right? What could be another variable, another thing that's related to these two things, eating disorders and social media, right? So think of some examples. Some examples I might think of as self-esteem. I might think of it in terms of the home environment. I might think of in terms of going through and having body identification. So all of those things are possibilities to, again, kind of what else could be related to these two things. So think of some ideas for these two examples, or at least one of them. The next part is a regression. So here I am giving you some information. I am telling you these two are related, right? They're related enough. So again, that's a precursor for running a regression. I also give you the means and standard deviations of the two variables. I am trying to predict number of close friends based on friendliness, right? So I want you to look at those means and standard deviations. And one of the things I ask you is, well, do they meet this assumption of normality? If I have a large standard deviation, that usually can give me an indicator that something's awry and I'm not having a normal distribution, right? So you're going to say yes or no and why you think that could be a possible issue. Then if I were going to do a scatter plot between these two things, what would I want? So again, going back to some of the assumptions for correlation as well as regression, what do I kind of need to see in that scatter plot to keep moving forward? What variable is going to go on the y-axis? And you can circle close friends or friendliness. And then I give you the slope and the intercept. And so I want you to go ahead and write that regression equation. Part D, you're just going to fill it in. I am giving you a friendliness score of 5, and you are going to plug and chug and tell me what is that predicted y. Then the last question goes back to this idea of generalization. As a researcher, even as a consumer of research, you need to decide how far could be generalized from the sample to a larger group. And so you get to think about that and give me your explanation. Again, there's going to be an answer key posted in the modules. And so that's what we had set up for class. Again, reach out to me with any questions.